I don't believe you. Okay. You got this? Principle of moments. Got this? Yep. Okay, so we're continuing from the center of gravity idea that we were looking at. Yeah. So have a look at this. What would happen if equal but opposite forces are applied at the ends? So in other words, tell me what would happen if there's a force going up here and a force going down here. What would happen? It would turn, wouldn't it? Now, if you draw that, and you say there's a force up here, let's say 100 newtons, and a force here, 100 newtons, then you might say, well, that's the same thing as no force, because this is up and this is down. But it is.
They are going in the same direction. Backwards.
They're going in opposite directions. This is up and this is down. I assume you know the difference between up and down. Yeah.
Well, if we like...
This is it now. Same direction, but direction of what? So here, this force is going up and this force is going down. So in total, there's no force up and no force down. 0, 0. Is there any force left? No. Is there any force right? No. So it doesn't move up, doesn't move down, doesn't move left, doesn't move right, but it does move. How does it move? Rotate. Because this force is moving this way, and this one is moving this way. So in total, it wants to turn. So now we have this idea. We have X, force in the X, force in the Y, and then force that makes it turn. It's like we have 3 now. An X, a Y, and what would we call this direction? Yeah, we call it clockwise, anticlockwise. Do we know this word clockwise?
Yeah.
We know clock. Wise. Wise doesn't mean anything here. So clockwise meaning with the clock. Anti-clockwise meaning against the clock. Yes? Do you know this? No. Okay. 12, 6, 3, 9. Moving this way is called clockwise. But moving this way against the clock is called anti-clockwise.
Why?
Why? So think about the clock. Starts here, and then does it go left or right?
Right.
Correct. Tick, 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 tick. So this is called clockwise. If you try to go backwards, that's called anti-clockwise. That's the name of it. Yeah. It's okay? These words are okay? Right. Next. Let's see, which we did. So it seems like it doesn't move, but it does. It actually is rotating. So this is the key word, equilibrium. This is what I'm trying to get to. We say something is in equilibrium if, if the total force is 0. And when I say the total force is 0, I mean the force to the left equals the force to the right. The force up equals the force down. And lastly, the clockwise force equals the anti-clockwise force. Then it's in equilibrium. That means it doesn't move. Doesn't go up, doesn't go down, doesn't go left, doesn't go right, doesn't turn. This is equilibrium. Completely equilibrium. Okay, so now you need this, is important result. Got this? Yes, got this? Continue? Yeah. Okay. You have this wrong? Yeah. The last point is in fact, so this last point here is called the principle of moments. Although, yeah, no, whatever. That is, the sum of the clockwise moment is equal to the sum of the anti-clockwise moments. In other words, the total clockwise equals the total anti-clockwise. Right, we have a couple of examples to do. Let's try this one together. So I just need you to draw the picture. A 40 kg boy sits at the end of a 100 kg seesaw, and his sister, 30 kg, sits at the other end. The pivot is in the center, but the seesaw is not balanced, so it starts to move. So their father decides to fix this by moving the pivot. Where must he put the pivot? So in other words, if the boy sits here and the girl sits here, the boy is heavier, so what will happen? It'll go down and she'll go up. So the father says, I'll fix this by moving the pivot so it's balanced. This is what we want here. So can you just draw the situation, and then I'll do it with you. So just draw what we have here.
Do we get a number, or do we just get a direction?
Well, we get a number. Yeah, we get a number.
Do we draw it with the new pivot?
Yeah, the new pivot location. Yeah. This is a question I don't have an answer to.
But if this is so, it will be balanced or it can play.
No, actually, we want the seesaw to be balanced, because at the moment, what will happen is the boy will go down and the girl will go up, and it will stay like this. But if it's balanced and it's neutral, then that means a little force could make it move. Yeah. Okay. Can I redo this one now? Yes? So, what's the boy's mass? 40. So there's a force here of 40G, and here 30G. And there's another force, do not forget. The weight of the seesaw does matter, 100G. So where should we put the pivot? Left, right, middle?
Left.
Somewhere like here.
Yeah.
Yeah? What do you
But
think?
then does that make it balanced?
Well, we don't know where to put it. We want to find where to put it.
It's around that area.
I think that's
Yeah.
we should divide it.
Well, what we'll do is, I'll call this distance from here to here X. And then this distance and then this distance. Now, this last one we know. What's this one?
2.5.
Very good, 2.5. The middle to the end is 2.5. What about from here to here?
That's 2.5
Minus x, yeah.
2.5 minus x.
Yes.
Yeah. Now, there are how many forces here?
Great.
3 forces. No.
2.
No. How many forces? How many forces? One? No.
No, what?
Forces. How many forces in total? How many forces?
0.
See, I love that we started with 3 and we decreased from 2 to 1 to now 0. Does anyone want to suggest minus 1? We have to move the other direction now. There are 4 forces. There is one force I didn't draw.
A reaction force, yeah.
Of course, because in this diagram the seesaw would fall down to the earth. There's one force here at the pivot, which is the reaction force. And this must equal
This
this plus this plus this. Otherwise, down it goes. Now we're thinking, mostly. Okay, so I could say or equals 170g, but that's not helpful because that doesn't tell me what the x is. This force compared to here, will this make it turn clockwise or anti-clockwise? Are you all sure?
Yes. Like if it was in the middle.
Yeah, this is the center.
Yes.
Oh.
This one would make it turn anti-clockwise. This one
Clockwise.
would want to make it turn clockwise compared to here. This one, clockwise. And this one, why not?
Because it's on the pivot.
So delete
The
it.
distance is 0.
Yes, the distance is 0. So this force should equal these two. What is the turning force here? 40g multiply x. That should equal this one plus this one. So, what would be this turning force here?
100g times.
Yeah, 2.5 minus x times 100g. And then lastly, this one?
50g times 2.5.
No.
Times 2.5 plus 2.5 minus x.
2.5 plus 2.5 minus x times 30g. Okay, what's your question?
The weight of the whole seesaw is 100g.
Yes.
So it's not only acting in the middle.
The 100g is the weight of the seesaw, the physical seesaw, not anybody else on it, yeah?
Yes. So even on the left side of the pivot, there will be a weight of the seesaw.
But remember, we said at the very beginning of the first lesson, center of gravity is the single point which the force appears to act.
Yeah.
Yeah. Yeah. So your question is... give it to me. What are you saying?
Don't we neglect the weight of the...
But we didn't. It's right here. The weight on the left and the right is all represented by this single force vector in the center. You know what I mean? We've not neglected them, we've just reduced them to one vector. You don't seem happy. No. But it's true. You're thinking, shouldn't I put a force here and here?
No, shouldn't we remove the 100g?
And replace it with what?
Not replace it with anything.
Oh,
Because 30g and 2.5 plus 2.5 minus x would equal the 40g plus x.
No,
but this seesaw has a weight. We can't ignore
Regardless
that.
of the weight of the seesaw,
No.
this would equal this.
No, but then that's heavier. Because the pivot is shifted, I think that would be heavier. So maybe if we divide it, let's say 75% of it, so 75 G's on this side, and then on this one, like 25% of the weight.
We
don't know the percentages.
no, but we can't, the point is still true, we cannot ignore the weight, because the weight, imagine those people got off the seesaw, and we kept the pivot here. This would turn, because of the weight of the seesaw.
Yeah.
So we can't ignore this into the turning effect, you know?
Uh-huh.
The only time we could ignore this is when? When could we ignore the weight?
When the pivot is
If the pivot was at the centre of gravity, then we could ignore it. But we can't because it's not. Right, I want to solve this. What's the easiest way to solve it? What should I do first? First thing? Yeah, but even before that,
So you should move.
Remove the G.
remove the G. The G's and everything, yeah? So we get 40x equals 2.5 times 100 is 250 minus 100x plus 5 times 30 is 150.
No,
2.5 plus 2.5 is 5. 5 times 30 is 150. And then minus 30x. So that's minus 130. To the left is 170. And then 250 plus 150? 350. So x is 350 over 170. So 350 over 170. 170.
2.06.
2.06. So here's the seesaw. Here is where the old pivot was at 2.5 and 2.5. He should move it so that it's now 2.06. So how far to the left does he need to move it? Move 0.44 meters towards the girl. Well, we drew the girl on the left. This is the answer then.
What's the total weight of the
boy.
What's the total weight of the
Oh, did I drew the... Sorry, to the boy, thank
Isn't
you.
the total weight 5?
Of the whole thing?
Yeah, the whole thing is 5.
Oh, the total length is 5 meters, yeah.
Yeah. And we got x as 2.06.
Yeah,
So isn't it 2.5 minus 0.
2.06?
Yeah.
Is that not 0.44?
Yeah, there.
It's right,
2.5 minus.
Okay. Well, man,
It's okay.
it's a long day.
Oh, you're telling me. Okay. So what we'll do is,
Should you write this?
yes, you should. We'll split this lesson up and we'll continue it the next time. So if you just write this down, I won't give you any homework because I'll collect your assignment in the next class. So you have no reason for it not to be finished by the next class because I gave it to you last week, didn't I? Yeah. And our next class is tomorrow? Okay. Yeah, just finish writing this down, please.
My answer is not, it's different.
What answer did you get?
2535.
Maybe it's my mistake. I'll tell you what, we'll check it again in the next class, okay? Just show me what you did next time. Maybe it's my mistake. Okay. Sorry, can I close this?
Yeah.
You sure?